most familiar foods on Earth. It sits quietly on tables, in restaurants, and in homes across the world, often overlooked, rarely questioned. Yet behind this simple red sauce lies a complex system of agriculture, chemistry, engineering, and logistics. Every bottle represents thousands of decisions, precise measurements, and carefully controlled processes. This is the story of how ketchup is made, step by step. Every bottle of ketchup begins far from factory floors and supermarket shelves. It starts in vast agricultural regions where tomatoes are grown not for appearance but for performance. These are processing tomatoes, bred for thickness, durability, and high natural solids. Unlike fresh tomatoes, processing varieties contain less water, thicker skins, and fewer seeds. This makes them ideal for large-scale manufacturing, where efficiency and consistency matter more than shape. Inside each tomato is a precise balance of sugars, organic acids, pectin, and water, a natural chemistry perfectly suited for ketchup. Climate also plays a critical role. Hot, dry growing conditions stress the plants, increasing sugar concentration and improving flavor. Once ripe, timing becomes everything. Tomatoes destined for ketchup must move quickly because freshness, color, and acidity begin changing the moment they are harvested. Processing tomatoes are harvested mechanically. Specialized harvesters move through the fields in a single pass, cutting vines, separating fruit, and removing debris at remarkable speed. Inside these machines, vibration and gravity replace human hands. Despite the scale, handling is gentle. Rubberized surfaces and controlled drops reduce bruising, preserving the tomato's internal structure. Within minutes, tomatoes are transferred into food-grade trailers, each carrying several tons. There is no cold storage here. Instead, speed is the preservative. Factories typically require tomatoes to arrive within hours of harvest. Heat buildup accelerates spoilage, so rapid transport keeps the fruit stable without refrigeration. As trucks approach the factory, each load is logged, weighed, and traced back to its source field, creating full accountability before processing. Can be transformed. They must be cleaned thoroughly. At the factory intake, tomatoes enter large water flumes where dirt, dust, and field debris are removed. High-pressure water jets scrub every surface. The water itself is carefully controlled. Ozone or mild chlorine levels neutralize bacteria and mold while remaining food safe. Next comes machine vision. Optical sorting systems scan every tomato in milliseconds, analyzing color, size, and surface defects. Any tomato that doesn't meet strict standards is removed instantly, pushed aside by compressed air jets faster than the human eye can track. Metal detectors and magnetic traps follow, ensuring no fragments of machinery or foreign material pass forward. By the end of this stage, only clean, intact, and standardized tomatoes remain. This is the point of no return. Clean tomatoes drop into industrial crushers, where mechanical force ruptures cell walls and releases juice, pulp, and seeds. Immediately, temperature becomes critical. For ketchup, factories use hot break processing, rapidly heating the pulp to deactivate enzymes. Without this step, enzymes would continue breaking down pectin, causing ketchup to separate and thin over time. Seeds and skins are removed using centrifugal separators, leaving behind a smooth tomato puree. Next comes concentration. Large evaporators gently remove water under controlled conditions, intensifying flavor while preventing scorching. Technicians monitor the process using Brix measurements, ensuring the paste reaches the exact solids concentration required. What emerges is tomato paste, thick, stable, and ready for formulation. Tomato paste alone is not ketchup. In the formulation hall, ingredients are added with extreme precision. Vinegar establishes acidity. Sugar balances flavor and texture. Salt enhances taste and preservation. Spices are not added raw. Instead, factories use controlled extracts, ensuring identical flavor in every batch. Acidity is critical. With a pH around 3.6, ketchup becomes hostile to harmful bacteria, allowing long shelf life without refrigeration. Sugar plays multiple roles. Beyond sweetness, it influences viscosity and how ketchup behaves when poured. High-speed mixers emulsify the mixture, binding water and solids into a stable structure. This is where ketchup's unique behavior is engineered. Cooking locks everything in place. Steam-jacketed kettles heat the ketchup evenly, preventing burning while developing flavor. Modern factories often use continuous cooking systems, controlling time and temperature to the second. Heat dissolves sugars, integrates spices, and stabilizes acids without caramelization. Next comes homogenization. High-pressure homogenizers force ketchup through microscopic gaps, breaking particles down to uniform size. This creates the smooth texture consumers expect and prevents separation during storage and transportation. Every degree of temperature and every second of cooking is monitored. There's no room for error. Before bottling, ketchup must prove itself. Samples are tested for acidity, sugar concentration, and viscosity. Flow tests ensure it pours correctly, neither too fast nor too slow. Microbiological tests confirm safety, while stress tests simulate months of storage and transportation. Bottles are shaken, heated, and vibrated to ensure seals hold and texture remains stable. Only batches that pass every test move forward. Anything else is rejected. Approved ketchup flows into the bottling hall. Empty bottles are sterilized, then filled using volumetric systems accurate to fractions of a milliliter. Anti-drip nozzles prevent waste at high speeds. Caps are applied instantly, forming airtight seals. Many bottles receive induction-sealed foil barriers, an added layer of safety. Labels and date codes provide full traceability, linking each bottle to its production history. Robots take over next, stacking, wrapping, and preparing pallets for shipment. From the factory, ketchup enters a global logistics network. Automated warehouses store millions of bottles under stable conditions. Shrink-wrapped pallets prevent movement during transport. Ketchup's long shelf life comes from its design, acidity, sugar, and controlled cooking working together. Before shipment, bottles undergo vibration and temperature simulations to ensure durability. Only then does ketchup travel, by truck, rail, and ship, to stores and restaurants around the world. Ketchup behaves unlike most liquids. It is a non-Newtonian fluid, thick at rest, flowing only when force is applied. Tapping the bottle redistributes internal stress, triggering flow without a sudden surge. Bottle shape, opening size, and material flexibility are all engineered to work with ketchup's physics. Once poured, the structure rebuilds, allowing ketchup to cling to food instead of running off. What seems simple is anything but. From farm fields to factory floors, from chemistry labs to global supply chains, ketchup is one of the most precisely engineered foods on Earth. Every bottle represents science you can taste. And now you know how it's made.